In this video, I'm going to introduce you to changing the subject of a formula. Here is a formula, V equals U plus AT, and currently we would say that V is the subject of that formula because V is equal to something in terms of the other variables where V is not on that right-hand side. V is only on the left-hand side, so if you knew U, A and T, you could substitute them into that formula and it would tell you V. So V is currently the subject of the formula. Okay? Now, this formula you may recognise. This is one of the constant acceleration formulae, otherwise referred to as a SUVAT formula. And the idea is that it relates the final velocity of a particle with its initial velocity, the particle's acceleration, and the length of time over which it is accelerating. So what we do is we often write down SUVAT, but I'm not going to bother writing down the S because S has got nothing to do with this one. S represents displacement. So let's just write down U, V, A and T. Now imagine that you knew U, A and T. So let's say we knew that U was 2 meters per second. I'm not going to worry about writing down the units, but I'll refer to them as we go. Let's imagine that the acceleration is 3 meters per second and the length of time is 4 seconds. So I can substitute that information into my formula to work out V. V is equal to 2 plus 3 times 4. So V would be equal to 2 plus 12, which is 14. So the final velocity would be 14 meters per second. Now, imagine that we didn't know U, but we knew that the final velocity was 20 meters per second. And I wanted to work out what the initial velocity was. Now, fine, I could still substitute that information in. V is 20. U, I don't know. The acceleration is 3 and the time is 4. So 3 times 4 is 12. Subtract 12 from both sides and I get that U would have to be 8 meters per second. So I can still do it, okay? And I'm not saying that you can't. But there are formulae much more complicated than this where it would be useful if I instead had made U the subject of the formula. So, sometimes you might see in textbooks or older textbooks the notation of writing this. So what this means is that V is the subject of the formula. Okay? So if I was to make U the subject, the whole idea would be of me rearranging this formula to make U. So, what would I do? Well, I would remove the AT first, so subtract AT from both sides. Is equal to U. And I've kind of done it, but I would probably want to write that as U equals V minus AT. Okay, and so now I've made U the subject. U is on the left-hand side, and on the right-hand side is everything else. So now, if I plug in my information, I'm going to get 20 take away 3 times 4, and that gives me the 8. So 20 take away 12. Okay? So rather than plugging in the information first and then rearranging, I've got a rearranged formula. I've made U the subject. Okay, but of course, I might not have that information that way round. Let's say that I know that this is 10 and this is 20, but I don't know the acceleration. Now again, I could plug that information all in here to work out the acceleration. Alternatively, I could rearrange this to get A as the subject of the formula. So I could subtract the u from both sides, and now, because I've got a times t, I could divide both sides by t to leave myself with this. So I'm just going to write it this way round. So a is v minus u over t. It is now in a form where I can just plug everything in that I know and I can work out a. So a is now the subject of the formula, and I would have 20 take away 10 over 4. So that's 10 divided by 4, which is 2.5. Okay? So I've made a the subject. Now, alternatively, of course, maybe I knew the acceleration was 8 meters per second. And this time, I wanted to make t the subject. So, to isolate t, I would subtract u from both sides first, like I did before. But rather than dividing both sides by t, because I want to leave t where it is, I'll divide both sides by a. So t is v minus u over a. I have now made t the subject of the formula. So I can now plug in my information. I've got 20 take away 10 divided by 8. So 10 divided by 8 is 5 divided by 4, so that's 1.25. Okay? Now, with a simple formula like this, you might be going, well, rearranging first and then substituting in is of similar difficulty to plugging the values in and then rearranging. That may well be true. But the rearranging of formulae is incredibly useful. It's incredibly important. The whole algebraic manipulation is really the bread and butter of mathematics. So understanding how you can rearrange a formula to get it into another form is very important. And we do rearranging of formulae, rearranging of equations all the time. So the more you get used to it, the more you practice it, the stronger your foundations mathematically will be.